Hello, this is Mr. Stansbury. I'm going to take you through the notes on solving right triangles. At the end of this, you should be able to say, I can calculate angle measures from trig ratios. Okay, so let's get through some important info on this. If we are looking to find what angle measure a given trig ratio makes, we have to undo the trig using inverse trig, okay? So, for example, if we know that sine of 35 degrees equals 31 over 54. So we know this angle here is 35, that side's 31, that's 54. That's opposite and hypotenuse, so that would be sine. So sine of 35 equals 31 over 54. Okay. Now, let's just say we didn't know the angle, so we had sine of the angle, but we know the ratio is 31 over 54. So sine theta equals 31 over 54. We know that theta is 35 because we have that here, but what if we didn't know? So what we have to do is we have to take this sine theta equals 31 over 54, so there it is in pink, sine theta equals 31 over 54, and what we have to do is we have to undo the sine because we don't want the sine of theta, we just want to know what theta is itself, right? So we got to get rid of the sine. So what we got to do is, really what we could do is we can divide by sine, right? And that would make that go away. But dividing by sine is the same thing as multiplying by its inverse, right? So that is why we multiply by sine to the negative first. So sine to the negative first and sine, those will cancel out and give us just theta. So that's what we're looking for. We don't want to know what sine theta is. We want to know what theta. We want to know the actual angle. So this here is going to be our theta, right? So if we take inverse sine of one side, we got to do inverse sine of the other side. So that means theta is going to equal sine to the negative first of 31 over 54. So if you get your calculator out, we want to put this into our calculator. Now we're used to pushing sine, but if you look right above sine, there's sine to the negative first. So what we do is do second sine, and that gives us inverse sine. Okay, so whenever we're looking for an angle, we're always going to do inverse sine. Okay. So sine to the negative first of 31 over 54. So now we do 31 divided by 54. And we take this inverse sine of that, and there's our 35 degrees that we already knew that was. Okay? So again, here, let me just show you this. This will help out, I think. So here's some examples. So we have two sides, and we have to figure out what the angle is. Have two sides, got to figure out the angle. Have two sides, got to figure out the angle. Whenever we're looking for the angle, we got to undo the sine. So we have to do inverse sine, or inverse cosine, or inverse tangent. Okay? So let's write our SOHCAHTOA down up here. SOHCAHTOA. So we can use that to figure these out. Okay, here's the angle that we have. From this angle, what are the two sides that we know? We know that this is the hypotenuse, and this is the adjacent, because it's right next to. That's the opposite, but we don't have that, so we don't even bother to write that down. Adjacent and hypotenuse is cosine. So what we want to do is do cosine. Here's really what we're doing. Cosine theta is, we know, has to equal... cosine's adjacent over hypotenuse, so it's going to be 22 over 34. But again, we got to get rid of that cosine, so really we do cosine to the negative first of those. So really what we're doing is we're doing theta equals cosine to the negative first of 22 over 34. Okay, and that's where this handy-dandy calculator is going to come in handy here. Okay, so we don't want cosine, we want inverse cosine. So second cosine gives us inverse cosine, and then we do 22 divided by 34, and that gives us 49 point, let's go just to the nearest tenth, 0.7. So this is going to be theta equals, I already forgot, 49.7 degrees. Okay, so that's what this angle here has to be if this is the ratio of the two sides. Okay. On B here, let's see, here's our angle. We don't know the hypotenuse, but we do know the adjacent, and we do know the opposite. So opposite and adjacent is tangent. So if we want to go straight to the good stuff, we know that theta is going to equal, we got to undo the tangent, so it's tangent to the negative first of, let's see, tangent, sorry, is opposite over adjacent. So opposite is 14, adjacent is 21. So now we just plug that in. Second tangent gives us inverse tangent, 14 divided by 21. And we get that that's 33.7 degrees. 33.7 degrees is our theta on that one. Okay? And then this one here, here's, let's see, this is opposite of the right angle, so that's the hypotenuse. This is across from our angle, so that is opposite, and that's the adjacent, which we don't need to know. Opposite and hypotenuse is sine. So we're going to do theta equals sine to the negative first of, and then sine is opposite over hypotenuse, so that's going to be 42 over 53. Okay, so second sine of 42 divided by 53, and we get 52.4 degrees. Okay, so this is finding an angle if you have two of the sides in the right triangle. Okay, I got one last example for you, but before we do that, let's take a quick little comedy break.
5-year-old boy holding a helium balloon, and he accidentally let go of his balloon. The boy started crying, and his parents are like, "Why are you crying? It's a balloon. We'll get you another one." I'm like, "Japers, crapers, folks." Sometimes I don't think adults try hard enough, to understand what kids are going through. If you wanted to relate to what he's going through, imagine if you took your wallet out and it just started floating away. Why are you acting like that? It's a wallet. We'll get you another one. I want that one! All right. Here we go. Let's take a look at this one here. Trixie measures the distance from the bottom to the top of the world's largest venti sugar-free, non-fat vanilla soy double shot decaf no foam extra hot peppermint white chocolate mocha with light whip and extra syrup, ever made, as 47.5 feet tall. What is the angle of elevation to the top of the cup if she stands 80 feet from the base of the cup? Okay, so what we want to do is we want to draw ourselves a little picture here. So here's our cup, and here's the height of the cup, and we'll call this the base. I know there's a little bit of space in there, but let's just call this the base to make our life easy. And then what we're trying to do is she's standing over here, and we're trying to figure out what the heck is this angle right there. Okay, so again, we know that the height of this thing is 47.5 feet, and she is standing 80 feet from its base. We want to figure out what that angle is there. Okay, so we take a look at this, and this here, this side is from that angle, that's the opposite, and this side here is the adjacent, right? So that would be tangent. So whenever we're looking for the angle, tangent, inverse tangent, tangent to the negative first of, and its tangent is opposite over adjacent, TOA, right? So 47.5 over 80. Okay, so get our calculator out and calculate that, and away we go. So second tangent of 47.5 divided by 80 gives us 30.69, so that's 30.7 degrees. So theta equals 30, oops, I already forgot, 30.7. 30.7 degrees, because this here is theta equals tangent, the negative first of 47.5 over 80. Okay, so that means she's looking up at an angle of about 30 degrees or so to the top of that cup. Okay, all right, that's all we have for solving right triangles. If you have any further questions, please feel free to ask in class. Thanks.